So today I want to add some events for monitoring the context size. Okay. So Clanka, for those who don't know what it is like I posted about it on Twitter X not that long ago. But essentially it's an effect toolkit for writing coding agents. And I'm currently dog fooding it on my day-to-day work. In my Louth project. Louth is my agent orchestrator that I use for. I assign tasks to it, and it basically works on tasks that I assign to it. But Clanka is an experiment for testing out different ideas around coding agents and tool calling and alternative ways of approaching the coding agent problem. So if I look at agent module, agent is kind of like where the agent loop lives. And at the moment, when you create an agent, it does nothing until you send something. And then when you do send, it gives you back a stream of output. And then when it finishes, you get the agent finished error. Or it could fail with another error. So in this output right now, we have a bunch of events. So you can like listen to these and then pipe them, string them somewhere, or there's this output formatter module that takes these events and like prints them out to the console. But I want to add one for token usage. So in here, I'll copy the script one. And I'll just create an output class called usage. Input tokens. And output tokens. Let's do that for now. And then we'll add them to this union. Usage. And to this union too. Yeah, we probably could just do like content part. Is it members? And this one just adds, it's agent start as well. So there's like a couple of unions here. One is shared by sub-agents, and then this is like the final output structure. There. Where you going here? That's good. So this is where the usage is. Not usage. Agent ID. So we want to send new usage part. Dot usage dot input token. Usage. I guess we'll only send it if we have access to it. So if it's not undefined, then we'll set that. What else have we got here? Usage dot output tokens dot total. And I guess we'll need to have like a running total. So maybe if up here we have some state, and it will be per agent output tokens equals 0. And then here we can go the usage to output tokens or total is not defined, and let's do that. Okay, so we've added this part, and now we're going to be getting some type failures in here. So we're going to use this message. I think we could use maybe cyan. Yeah. We need an info icon. Okay. So here we go. Maybe if we just do colon. Don't want this to take up much space. I'll just keep it on one line. And then if we go output dot input tokens, output dot output tokens. Output. Let's see what that looks like. What is it? It's like we need some new lines in there. I feel like we need an icon with a bit more solidness. Maybe that one. I'll put full better. Info icon. That one. Yeah, maybe we should use like a number formatter so it has like the old commas, the separators. So I think there's like a hello, Mike. I think there's what is it? Number formatter. Yeah, that's it. No idea what the options are. Constructor type. Maybe we'll just see what the defaults look like and go from there. Number format dot format. And we wanted some more new lines. Alright, so starting message, usage. Oh yeah, that's good. So now I can just monitor the context window size. At the moment, there's no compaction built in, but for my use case, it's fine. But at some point, probably need to look at compaction. But I feel like if you've got to the point where you need to compact your prompt, your task is too big. It would be interesting to see how big it gets, the context window. Maybe I can compare with open code. What was my prompt? Maybe here instead we'll go open code, run. And we get the same model. OpenAI using 5.3 codecs at the moment. Variant. Do they so show usage here? I think they do. Or maybe they just show it at the end. I like seeing like the full text of what's going into the context window. One thing I've been experimenting with is WebSocket mode for OpenAI. I feel like it definitely does reduce the latency quite a bit. It definitely feels faster with it enabled. WebSocket mode. So instead of sending like the full prompt every request, you just send the new messages, and you also don't have to like spin up a new HTTP connection every time. You can read up about it on the OpenAI developers website. That's pretty cool. It's definitely something I should have done sooner, but I guess the whole using AI for coding thing came a bit later after the general chat usage. So Clanka was done in 3 minutes and used just over 100,000 input tokens. Open code is still going. What is it doing at the moment? It's looking at the open code provider. What else has it been looking at? Looked at the session stuff, Copilot package. Yeah, so they were pretty much done in the same amount of time. That's annoying. I can't see the usage. I'm sure there's a way of accessing like the session information. Would it be in my doc files? Local share open code. The log. What's the name? Much? That'll be that one. Is that the usage steps there? Nope. Storage. I'm guessing that's just like there. Oh, we got session. Alright, I was going to rerun it. Copy that. Open code. And we want to use music codecs 5.3 on high. That's annoying. I just want to copy paste. There we go. Yank that. All right, now we can see usage. At the moment, I've just been comparing agents using metrics like time and token usage. But I want to get some proper evals set up for this. Probably in the Perfect version 4 repository. But while that's going, I'm pretty happy with the usage part for now. So change set, output to usage. Push that. So it's at 30,000 tokens. What is the token limit for 5.3? GPT 5.3 codex token. 400,000. Feel like we've got some room to improve then. So this used 100,000, so that's a quarter. We scroll back and see where that went. So it's at 100,000 there still. 95, 94, 93. So it jumped from 74 to 82 there. So that used 10,000 tokens. I'm guessing from the read file. Oh yeah, so called read file without setting any ranges. Oh yeah, I got some ranges here. I guess that's fine though, because that's like, I feel like a pretty key file for this task. Were there any other big jumps? Oh yeah, we went from 5,000 tokens to 73. Because Looks like the lock file got into the grep. Yeah. Let's try that and see what we get. So that's the pattern. So pattern, repos, open code, stuff. Yeah, there'll be a lot of references to OpenAI and open code base. Does the lock file make it in? Yeah. Yeah, that's not that dense. It's just a lot of matches here. Maybe what we could do is add like a files only mode. And then that way it's not reading like all that content into the context window. We could try that. So we go to agent tools. What does rep call that option? Files matches. Maybe we'll just call it files only. Files matches. And then maybe we could put something in the system prompt to recommend using this. So we go to the system prompt, generate system. I think we'll put something in here. For in using RG over a large code base. Prefer Prefer using the files only option. For looking at file contents. Try to see how it performs. So what I want to see is not 70,000 tokens of rip grip. It's definitely better. So call rip grip, past, files only. We went from that's about 4,000. And then we had about 15,000 tokens from a rip grip, but this one is a lot more specific. And I think that's fun. Files only again. Oh, yeah, what's funny? I didn't actually use that option. Funny. Rip grip. So if options files only. Yeah, there we go. Right, let's try that again. Is this the 24-hour classes stream? No. I don't have that much patience. So did it work? So I went straight into rip gripping for the exact pattern. There's reading file ranges. Let's do some more specific gripping. So I don't think it's actually used that option in this run. But at least it hasn't jumped to 70,000 lines of, or 70,000 tokens. One thing I did try was like adding a search tool that delegated to another agent and then just having it give back a report to save tokens, but it's quite slow. I feel like there's still some gains to be made in this area. Rip grep is quite a primitive tool. So some kind of like semantic code search would be helpful. And it's fine when the prompt is go out and find the stuff. But most of the time the coding agent is trying to learn the code base before it works on an actual task, and it takes quite a lot of tokens just to get to that point. So we're at 50,000. I feel like we're getting to the point where it's got enough information. Let's have a look. Saving as objects. Python. Interesting. So it generates embeddings for your code base. When was this made? 3 years ago. Actually explore one of those. This time it took 6 minutes instead of 3. but use considerably less tokens. Let's have a look at these guys. So that's one was quite old. This one's more recent. What languages? Requires running external services. Not sure if I want to do that. CLI first, commit it. Vector search. So you install it. MCP server. Okay. Okay, we can try it, see what it's like. I'm not sure if I even have Python on the system. Yep. What was that? Python 3 have it. Yep. Yep. 3. There we go. But 3 not found. Okay. Let's search. Hello. Enjoying effects and starting quite a big new project. It's going to be using effect version 4. Wondering if it's worth replacing BullMQ with effect cluster. I've actually never used BullMQ. Let's have a look. Background jobs and message queue. I mean, looks like this is more a job queue. We do have a persistent queue abstraction. Do I need that? No. Where is it? Oh, it's called persisted queue. So this module allows you to implement durable queues. and then you could probably use other parts of cluster for some other aspects. So effect cluster is built around the idea of the act model. So if you're familiar with Elixir or Akka, then you'll know a little bit about effect cluster already. But it's cluster mentioned. But it evolves around the idea of entities where you write your business logic as kind of like as entities. If I open a scratch page, so you could have like a counter entity. And cluster lives in effect unstable now. So you would have your counter entity and then you would give it some methods. So I pull in the methods are defined using RPCs. So increment, and this would take a payload of maybe like amount. And we use schema. Seem persistent queue, it costs a bit more appropriate with entities and stuff. You without knowing anything about like your domain and the problems you're trying to solve, it's hard to give like a specific solution. But with cluster, you create these entities, and then you can make like annotate particular like methods as persisted. And the moment you make like an RPC or a method persisted on your entity, then it will be durable. So if the machine crashes or it's like in the middle of a rebalance or something, then it will ensure like messages are retried and that they will always eventually be delivered. You can define counter and then go on the counter layer. And then here you would like initialize your state, like you could get it from a database here. In this case, just in memory. And then you can write your return of handlers. You don't really need to use spans here because everything is traced for you. Maybe just function. And there you go. Well, that's payload. What else do you get in there? You get the payload, headers, and a bunch of other stuff. Request ID, address. So you define your entities like their contract, then you implement them, and then you can run them on a cluster by first create like a cluster layer. So there is a module called runner, single runner. Yeah. And that allows you to run like a single node cluster. So you don't really get like the distribution the whole point of cluster is running like lots of nodes, but if you just want to play with clusters, then maybe doing a single node cluster. What is a snowflake? Snowflake is just a numeric ID that embeds some information. So I think Twitter was the initial kind of like advocates for snowflakes. Snowflake ID. So it's like a 64-bit integer that embeds like a timestamp and like some other sequential other data. So it has a machine ID and a sequence number. And they are sortable. So like when you do a query in the database, you can sort by the Snowflake ID. And it's exactly the same as like sorting by a created at timestamp. Which also means like in the Snowflake module here, you can like pull out the timestamp or the created at date time from a Snowflake or the machine ID or the sequence number. Domain you're working on is payment processing. Multi-step job for a single payment. You could potentially use workflow for that, which runs on cluster. So workflow is good for that kind of like sequential multi-step stuff. We have a README for it somewhere. Workflow README. So workflows are similar to entities, but they still require a name. And then you have success error payload, but then you need to define like an item potency key. And this would potentially be, in your case, like the transaction ID or something. This ensures like if you, for some reason, the workflow gets triggered multiple times with the same ID, that they get deduplicated. And then you define a layer, and then workflows like are a series of activities, and each activity is only ever run once. So if the workflow for some reason gets retried and this activity is already completed, then it kind of like gets skipped over and the result is pulled from storage. And then it has things like durable clocks and durable deferreds that allow you to interact with the world. So durable clock allows you to sleep for long periods of time without it consuming, without it being in process. So this here could be like sleep for 3 months. And while that 3-month sleep is in progress, it's just like an entry in the database. It's not actually in process. And then you can have durable deferreds. And durable deferred allows you to like send signals into your workflow. So when you await a durable deferred, it will actually pause the workflow. So it's only a database entry. And then once you kind of like send a value to the durable deferred, then it will wake the workflow back up. So you can use this for like integrating with confirmation emails and that kind of stuff where they have to click a button. But I think for payment processing, workflow is a good fit. 10-minute playwright browser session that needs some user interactions in its lifecycle. Yeah, potentially an entity, a class entity would be better for that. There's a module and cluster that I haven't really promoted much called entity resource. What it allows you to do is like wrap a resource that will keep the entity alive while it's running. So this could wrap a playwright browser session, and then you could have like methods on your entity for sending signals, which would be the user interaction in your case. So you could go entity resource make, and then you would do like your resource acquisition in here. So maybe for now we could just do like a pub sub or something. What else are we on here? Idle time to live. So idle time to live is like if there's no interaction with this resource for a certain amount of time, then just let it die. So you could say like 5 minutes. So this will kind of like manage this pub sub, which is a bit of a contrived example. But if you wanted to like integrate with external resources, there's like this close scope you can access. Entity resource.close scope. So entity resource gets 2 scopes. One that gets triggered on rebalance and things and on like machine restarts. And then there's this closed scope, which only ever gets finalized when the resource is shut down. So that means you can have like an external resource attached to this closed scope, and it will kind of like be tied together with your cluster entity. And it's like a wrapper around this for like managing a Kubernetes pod spec with entity resource. So you could have like a browser and a Kubernetes pod that you interact with. And then here you would just like put your pod spec. So you could have like the idle time to live will trigger finalizers. Yes, it will. But depending on which scope you use, so you can like access the standard effect scope, and the scope will be finalized like machine restarts and like shard movement. So if your entity moves to another machine, then this will be triggered. Whereas this one is only ever triggered when the resource is finally shut down. So use this one if your resource is like in process, and this one if you're managing an external resource. So here you could put like your Puppeteer browser. Like if your browser is like in an external sandbox somewhere, then you probably want to attach it to this one. But if it's just an in-memory browser, which I probably wouldn't recommend because browsers take a lot of resources. You can attach to this one. And then you get back your resource and then you can use it. So here we're going to go like that resource. And then in your methods, you would be like pub sub equals resource.get. And now you have I need to actually return it. Yeah. Now we have our pub sub. And if you want to like manually stop the resource, you can call resource.close. And that will like that will just shut it down immediately. Yeah, so in your case, your browser could be up here, and then like your entity methods are like your interactions with the resource. Will this stream be available as a VOD? I don't know. That's the answer. I don't make those decisions. But you can have, if I go copy, paste, and then I can include the link somewhere. Look, there you go. What was I doing before? I was looking into vector search. Vector search. I was installing, but I guess this one. Put that under Python. What is my current Python version? Python version 3.13. MCP vector search. I guess the other problem is that models are like, I feel like they're heavily trained to use rip grep at the moment. Like, you don't really need to explain to the models how to use it. They just know. That's what they reach for every time. So even if you tell it, hey, I've got this cool new search tool, they kind of just ignore it anyway. Install. I just want to know how to use Nix is great until you need to do something that you haven't done before. Wonder if I can just use the built-in Mac Python. Could not find a version. Not found. It doesn't work with Nix. Yeah, I'm getting that feeling. Clone the source. With UV. Source. UV sync. Do I need to run a module in it? progress. I just need a Docker image or something. Python, eh? At least npm just works most of the time. I think I'm going to give up on that. And also the option to then to code search. Are there any other better options? That one required running something, running a server. What's this one? Python. How long does indexing take for these things? Grep AI. Still with on command sounds enticing. Show. Okay, let's give this a try. Grep AI init. Embeddings provider. I guess for now I'll just use OpenAI. Be nice if it like worked with your codex subscription. Local file. needs an open AI API camera environment. Okay. Let's do that. Stops, edit, secrets. And maybe I can use. Should I have one on my file system ready? Yeah, here's one. Right, well, that's working. Let's have a look at their quick start. So start indexing. And once it's finished, you can search. I feel like for a large code base, you definitely would want to use a cheaper model. Well, look, grep AI watch. The colors are all messed up. Alright, so it's done its initial search. We go grep AI. What can we do? What's a good search? Where agent tools is defined. What was the search word? Search. Interesting. It's not too bad. The web search tool is defined. Interesting. Let's try running it on the Effect version 4 codebase. That's the scan. The input maximum request size is 300,000 tokens. Okay. So it's not that reliable. Can you configure their chunk size? Llama. Maybe I'll have to play with this in my own time. Anyway, I think I'm going to wrap up there for today. Thanks for your questions, and until next time.